Okay, let's get started. So I would like to welcome you guys to this Web8 Speaks webinar series. So before we continue, I would like to ask you guys to please raise your hand in this Go webinar software so that we can verify you're able to hear me. So please raise your hand in the software. Thank you, appreciate it. Okay, so my name is Fahim. I'm with Web8 Solutions. I'll be covering this particular session. So personally, I'm an Azure Solutions architect, and we work with APIs. And then back in the day, we used to work with SOAP services, and lots of companies, they are still using SOAP services, but definitely the trend is changing. Most people have started using REST APIs, and now we also have gRPC coming out as well. Some companies are actually already using it. So there are lots of technologies that are available these days. So let's cover the session. So it's about understanding what is API Lifecycle Management and what exactly is included in the overall lifecycle, and should you implement the whole thing or just some of the things that are offered by the API Lifecycle Management would be sufficient for you. So that's what we will cover in this particular session. So we will start off with what REST APIs are, what are the benefits you get with REST APIs, how we usually integrate our systems, how we or what exactly API lifecycle management is, what's the typical workflow when you work with APIs, and I'll show you a demo of how we can use some ready-made off-the-shelf API management solution, such as Apigee. You can choose to use Azure based technique as well. Like Azure has its own API management gateway. There are lots of gateways available. So you can basically use various ways to work with your API lifecycle management. Okay, so before we start off with what REST APIs are, please raise your hand. This way I can find out whether you're already using REST APIs. So how many guys are already using REST APIs? Thank you, appreciate it. So some of you guys are already using REST APIs, and how many guys are using SOAP-based XML services? SOAP XML services. If you could please raise your hand again. Okay, so some of you guys are also using SOAP XML services. So let's first of all talk about what a REST API is, how it's related to SOAP XML services, and then we will see how we can utilize the API lifecycle management concept to modernize our legacy applications. So REST API basically stands for representational state transfer. And what it means is that based on the combination of your URI, your method, like we have get, post, put, delete methods, and body, that can be your request body or also the response body. You can also use headers as well, HTTP headers, and status codes. So based on the combination of these, you get to represent the state of your overall request, and also your response will be determined based on that. So the goal is to query the backend. So you will have your front end and you will have your backend. Now, talking about backend and front end, it could be your database server. So if your application is directly connecting to your database server, sure, you can do it that way if you want. But these days, it is discouraged. We shouldn't directly access any underlying data source at all. Like database servers should never be accessed directly. Why? Because we have lots of issues. For example, security will be one of the issues. So security-wise, you're letting the application developer know what exactly your backend database server is. What's the connection string? What's the username? What's the password? What's the server name? So rather than asking every developer, the front-end developer, to directly connect to a database server, we usually ask them to go through a layer in between, that is your API layer. So API is Application Programming Interface. So let's first of all understand what exactly this API is. Why do we call it an interface. Why not call it something else, like maybe just a service? And yes, we do call these services as well, but overall we also call these as APIs, application programming interfaces. So first of all, let's have a basic understanding of APIs before we talk about REST APIs, web services, and so on. So basically APIs, the reason why we call these as APIs or interfaces is just like we have or devices, like you can have a desktop PC, you can have a Mac OS based machine if you want, you can have a laptop, you can have a tablet, you can have a mobile phone, and you can interface, you can connect to any device like a microphone, a webcam, etc. and so on by using some interface. So typically we have USB ports, or you can use the Wi-Fi devices. You can also use Bluetooth to connect one device to another device. So these devices, they are acting as interfaces in between. So you need to make sure that even though a webcam is a drastically different device, but your desktop PC or laptop, etc., should still be able to connect to it, you use some interface. So likewise, in programming world, we get to use REST APIs these days. They act as interfaces, so we can connect our front end to our back end. Or it doesn't always have to be the front end. It could be one back end connecting to another back end. Like you can have n-tier architecture in place as well. So basically, let me show you this diagram as well. So basically, say we have our front end application. It could be a web-based application. It could be a mobile application. It could be a desktop application. These days, we also have IoT-based devices as well, like Internet of Things, like smart home devices, security-based devices are there. Blood glucose monitoring device can also connect to the internet, and it can upload data to cloud as well. So you can have any type of front end. And likewise, you could have any type of backend. So for example, you could have your on-premises database server like SQL Server, Oracle, and so on. You could have your database server hosted on any cloud platform. It could even be your SOAP XML-based services, the legacy services, or at least these days, we call them as legacy service because REST APIs and gRPC has become more popular. So you might have a requirement to connect to these services. You might have a requirement to make sure that your front end should be able to access your legacy systems like mainframe-based applications and so on. Or you might have a requirement to connect to some other service as well. So before we talk about the last part, where we are connecting to this service that is connecting to some other database, in between we have this API, application programming interface. So RESTful services or REST APIs, they act as interfaces in between your front end and your back end. So this way you are decoupling your front end application from the back end. If you do not decouple, the drawback would be that your front end developer needs to know, like especially the desktop application developers, they need to know what database server you need to connect to. They need to hard code the logic and database connection strings and everything. So initially, if you're using Oracle, down the road you end up using MongoDB, or you end up using some cloud-based solution like Cosmos DB, DynamoDB, and so on. You will have to rewrite the code. So we do not want these application developers to rewrite code if you have decided to change your backend. So the backend should be independent of the front end and vice versa as well. So decoupling means write the logic in such a way that in future, these should be interchangeable. We should be able to swap out one technology with another technology without recording too much code changes in the front-end applications. The REST API acts as the interface in between the front-end and the back-end. So whoever is developing this REST API will have to connect to some data source directly. Yes, these developers will, whoever is developing this part, will need to know how to connect to SQL Server, Oracle, and so on. But down the road, once this API is in place, the interface is in place, any number of application developers, mobile application developers, desktop developers, web developers, they can use the same common APIs that we have here without knowing, are we supposed to connect to Oracle, SQL Server, what's the connection string? They don't need to know that. So only this layer will have to connect to some underlying backend layer in a technology specific manner, but your front end will be able to connect to this REST API without knowing what backend you're using. So this way we can swap out one backend with another backend. And this way you can basically even choose to have your legacy systems like mainframes as well. And as long as you have this REST API layer in between, it could use some legacy proprietary code or libraries, etc., to connect to your legacy systems. But once it's exposing these as REST APIs, now your legacy system is modernized. So we have modernized our mainframe sort of systems. Same goes for databases as well. You could have, let's say, some proprietary database server or sort of a legacy database server, and you can modernize it by creating this interface or the API layer on top of it. So all the front-end applications or other applications, they do not need to know what your underlying database server is and so on. So keeping this in mind, that the purpose of interface is to connect your front end to back end in an technology agnostic manner. And you should be able to change your technology with ease in future. Let's cover this in more detail. So typically, when you design your REST APIs, you do have to utilize these methods like get, post, put, delete, and so on. So I won't go into depth of how do we create all these APIs from scratch, but typically you have to make sure you first of all design them, create a specification for these REST APIs, and after designing the specification, you get to write some code in a language of your choice. Like you can use .NET. In .NET, you can use Web API project. You can use Java with Spring Boot. You can use Node.js. You can use Python. You can use whatever technology you want to create these APIs. And once these APIs are in place, you'll get these benefits. Like you're able to expose the logic over the network. So whatever your backend is, like your database server is, in this case, you're able to expose the logic over the internet or the network. So any application available anywhere will be able to connect to that particular REST API. And sure, you'll want to implement security as well, so that only the authorized developers and applications should be able to call these APIs. So basically, this is one of the benefits you get with APIs. You're able to expose any type of logic, any type of backend functionality over the network. Plus, you're able to decouple backend from frontend. That is very important. Like we discussed that in future, if you decide to swap one backend with another backend, then we shouldn't be required to change any code in our front-end application. Only the API should be updated. Only this interface or this API layer should be updated in case if you want to switch from Oracle to SQL Server, or from on-prem to on-cloud solution, or you want to connect to some SOAP XML-based service or some legacy system and so on. Only the API needs to be updated. Your front end doesn't have to be updated at all. So that is a benefit you get with decoupling the backend from the front end. Plus, you get to sort of secure your backend, because no front-end developer will ever know what exact machine is hosting your database server. What's the connection string? What's the username? What's the password? What's the host name? No one knows that anymore. And you can swap or interchange your technologies. You can, let's say, initially use SQL Server, change it to Oracle, or move it from on-prem to on-cloud. And again, no front-end will ever have to be changed at all. Likewise, front-end should be independent of the back-end. So you should be able to use any technology here, like .NET, Java, Node.js, Python, etc., and so on. So it's not just making the backend agnostic or independent of the front end, it's the other way around as well. So REST APIs, it's a universal way of developing your interfaces or point of contact in between the front end and the back end, so that it's totally independent of the technology or the language you plan to use. And another benefit you get with this is that you're future-proofing your architecture. So future-proofing is definitely very important. Things get dated. Back in the day, I had to learn COBOL. No one asks me to write any code in COBOL anymore. Fortran, no one asks me to do that at all. I spent quite a bit of time in FoxPro. No one asks me to do that anymore. So technologies keep on getting dated. So we should design our architecture in such a way that it should be sustainable in the long run. And future-proofing, yes, back in the day, there were several attempts to try to make the architecture future-proof. Like I mentioned that even in case of hardware devices, we have USBs. So when USB 2.0 came out, people said that, oh, it's super fast and it's the future. But later on, it got replaced by other versions of USBs and so on. People started using Wi-Fi's and Bluetooths as well and so on. So there's different technologies. So likewise, in terms of programming, before REST APIs came out, we had SOAP-based XML services. SOAP XML services. I'll show you SOAP XML services in just a bit, and I'll show you how to modernize those without writing even a single line of code. So you can modernize your legacy systems without writing any line of code by using the API Lifecycle Management concept. Even before that, we had so many other techniques, like we had CORBA, Common Object Request Broker Architecture. So we had so many different protocols and technologies that were promising that, oh, we will make things future-proof, but didn't really do much. REST APIs, yes, they are much more promising because they use the web standards. REST APIs, unlike the previous approaches, it uses the web standards that have been existing since forever. So that is why REST APIs should be utilized to future-proof our architecture until the next big thing comes out that will make things even more future-proof and so on. And you get to make things portable in a sense that, like I mentioned, that your backend could be moved from on-prem to cloud, and your front-end applications will never have to know what change has taken place, as long as the REST APIs, the interfaces in between, they are updated properly. So this way you can say that your applications are somewhat portable. So basically, you get these benefits with these with the REST API implementation. Now, when you create REST APIs, if you like this concept, that yes, we want to expose our database functionality over the network, or any legacy system, we need to expose its functionality in a more modern way over the network. Eventually, you will end up having lots and lots of APIs. So you will have REST APIs for, let's say, your sales application, for your marketing application, for your so many other applications. You will end up having microservices architecture in place where you have very granular application services. So when you have lots of services, how do you make sure that you're able to integrate things? How do you ensure that your front end, your client application, should be able to call your backend? So typically, it will be a point-to-point integration where every client application developer, or let's call it a front-end application, needs to know where exactly the API is located. So you need to know the exact API location. So your underlying system, like your database server or your other systems, it could be a mainframe-based system and so on, they are definitely not directly getting accessed, but the API is getting accessed directly by these client applications. So even this can become bad down the road. It will become very mishmash sort of thing. Like this client wants to talk to this API and this API. You'll basically end up having lots of point-to-point integrations. So in this case, how do you control things at the corporate level? How do you say that at the organization level, we should have some check and balance in place? So what client is allowed to call what API? So we need to make sure that these underlying APIs, they are made more secure, plus you're able to configure some policies, some rules, and standards at the organization level. So that is where you need to use the API lifecycle management concept. You need to use some API gateway. So we can implement some rules and regulations without making changes at the actual API level. So we'll talk about how we implement the policies. Let's actually talk about this. So basically, API management or API lifecycle management, one of the important things that we get to implement as part of the overall API lifecycle management is to introduce some API gateway. So the gateway will be in between your APIs, your REST APIs, and your client applications, your, let's say, front-end applications in this case. So previously, we just decoupled the front end from the back end. So the back end is definitely decoupled. These underlying systems, they're not directly accessed by the client applications. But at this point, the APIs are still getting access directly. So that is why we introduced this API gateway layer at this level. So all the client applications will now have to go through this particular API gateway. And all your underlying APIs, they will receive requests through this particular API gateway. So this is sort of your API management or API manager sort of solution. There are lots of off-the-shelf solutions available. And before I talk about some of them, the purpose of this API gateway here is to implement security. So you want to say that maybe not every application or API that we have developed here is secure. Maybe some developers know how to secure APIs, other developers don't know. But at the organization level, we need to enforce security. Global security needs to be enforced. So since we have this layer gateway in between the front end and the back end APIs, you can configure policies. And typically, when you use some API gateway solution, you get to implement policies in a declarative manner. So you don't have to write too much code. Instead, you get to use some graphical editors. You get to use YAML or XML sort of declarative syntax to configure some policies. So security-wise, you could say that we need to enforce OAuth or JWT token-based security is implemented. You can enforce this. You can say that whenever a request is sent by the client, it should be intercepted by this API gateway. And there our policy will say that it must ensure the token is injected, or the OAuth based token or JWT based token is injected, or it could be some API key that must be a part of the URL before it's sent to the underlying API. So you're able to enforce policies globally by using this API gateway layer. Likewise, you also get to check for threat or implement threat protection. So if let's say some malicious application is sending too many requests, rather than enforce or rather than having DDoS, distributed denial of service sort of attacks and so on, you can say that you want to reject those calls at this gateway level. So the gateway can reject certain calls, malicious calls especially. You can also use quality of service enforcement based policies to say that a certain client application is not mission critical. So you want to throttle the performance. You want maybe just 10 requests per minute, or maybe not more than that. It's up to you. You can configure that. Whereas for some other client application, you can say it is very mission critical. So you do want to allow pretty much, you just want to leave it open-ended, like how many requests are being sent per second and so on. So you can control that. You can control traffic. You can control quality of service-based policies. Protocol mediation. So you can say that here we have, let's say, HTTPS, but maybe once you need to connect to your API, you need to remove the SSL certificate, so you can remove that. So you can basically use protocol mediation concept like HTTP to HTTPS and vice versa. You can also change your data format as well, format conversion. So say your front-end application is sending data in XML format, but your backend API needs to receive data in JSON format. You can do that at this gateway level. Again, no coding is required in majority of the cases. Instead, you just need to do things declaratively, like using some XML-based tags, or in most cases, you have the graphical editors available. You just drag and drop and modify things by using the gateway features. So you can change your format from XML to JSON and vice versa. You can also implement load balancing. So typically the gateway has its own built-in load balancer. So this way, if there's too much load, you can specify that you want to redirect the traffic to some alternate API backup solutions and so on. So basically, there are lots of benefits you get with the API gateway layer in between your front end and the backend APIs. And again, you're doing things at the corporate level, at the entire organization level, by implementing or using this API gateway. And in just a bit, I'll show you a practical demo. In the demo, I'll discuss that if you have a legacy SOAP XML-based service and you need to modernize it, you need to convert it to REST API without writing even a single line of code. You can do that if you use the API gateway solution. So you'll be able to expose this thing as a modern REST API without writing even a single line of code. So this is the benefit you get with this API gateway in between. So keeping this in mind that APIs, they are very essential these days. They let us create the interface in between the front end and the back end. So this way they can both connect to each other without requiring in a more agnostic manner, technology agnostic manner. Let's cover this in slightly more detail before I show you a demo. So overall API lifecycle management, it does involve quite a few steps. Here we'll focus on just the important ones. So first of all, we should start off with the strategy. So IT department these days in an organization should identify what's the requirement of each business unit and what applications needs to be developed. And rather than asking developers to directly connect to the database servers and so on, plan these APIs first. So data, how the data is supposed to be exposed, plan that. And make sure that it is done in a more future-proof manner. Because if you directly connect your Java application to some database server, you're tightly bounding it. So there's tight coupling. And in future, if you need to change Java or you need to change your database server to something else, you cannot do that with ease. So that is why plan these APIs first. And then after planning, you can choose to start implementing these APIs right away. Or if you're using the API management solution, such as Apigee, or you can use TYK, WSO2. There are so many different solutions available. You can also choose to quickly test them out by mocking some data. So for mock testing purpose, you can say if I send a request to this particular URL, whatever your domain name is, then whatever your endpoint is, like let's say customers/1, it should respond me back with certain hard-coded data, mock the data. So you can basically perform mock tests with ease by using the API gateway layer in between. And even if you don't mock it, you can say that no, I just want to access the production ready data. You can implement your service and then deploy your service. Make sure it's made secure, like support JWT-based tokens, OAuth-based tokens, or you can use HTTPS protocol at least. You can use API key-based technique to secure your APIs. And after that, you need to manage. You need to make sure that these services are made available to other developers. So managing wise, I'll show you the developer portal tool in just a bit. That is also part of discovery, basically. So once APIs are developed, how do you find out what APIs are available to me as a developer? What are the features of those APIs? When to call what API? So you need to create sort of a documentation of your APIs. So service discovery needs to be implemented. And then after you have discovered your service, you have started using the service, you can monitor your services. Like who's using what API, how many times the API is called, what API is not popular. So you can basically monitor your services after they are being consumed by your developers and so on. And optionally, you can also choose to monetize your REST APIs. Like monetization might not be for everyone, but there are companies who benefit a lot from this monetization concept, such as Expedia offers lots of REST APIs, and you can basically call their APIs, but you need to pay to Expedia. So for hotel booking, for flight booking, and so on, you can call Expedia's APIs, create your own custom front end, but you need to pay to Expedia for each call and so on. Same goes for, let's say, Salesforce. So Salesforce also offers lots of REST APIs, and they are keeping track of who's calling their APIs, how frequently you call their APIs, and based on that, they have monetized their APIs. Same goes for, let's say, Google Maps as well. So there are several companies who create their APIs. They sell their data as a service. So they are selling their data as a service without ever letting you know whether they are using Oracle or SQL Server. They never tell us. They instead say these are the endpoints. You can call these endpoints, but you need a security token before you can call these endpoints. And then they are able to track and monitor the usage, and based on that, they are able to monetize these APIs. So even municipal entities and so on, they usually also not exactly monetize, but they offer these APIs. So you can look at some public figures, like how many schools are there, stuff like that, how many parks are there. So you can basically call APIs offered by other organizations. So if nothing else, you can choose to just call and or make your APIs discoverable, and then let developers know these are the APIs available to you, and you can monitor the APIs, see what APIs are more popular, what APIs are less popular, and so on. So basically, overall API lifecycle management involves lots of things, and when you use any professional off-the-shelf solution, such as Apigee or WSO2, you can use TYK, you can use Azure API management. They all offer these benefits. And as a case study, I'll show you a demo in just a bit. But before that, let me quickly talk about the overall workflow as well. So typically, the overall workflow will be, as a developer, you want to develop some application, but not from scratch. You need to acquire data from somewhere. So for that, the developer can visit something that is known as the developer portal. Developer portal is where you will have all the APIs listed. And then once you have chosen some service or a bunch of services or APIs you want to call, you're essentially accessing the APIs from something that is known as API registry. The API registry is where all your APIs will be located. And the developer portal is just the front end that's letting you explore how many APIs are there. And then these services will be called from from our API management by our application. So the application will basically consume the services from the API gateway solution. And you keep on adding more services to API registry. You keep letting developers explore and discover your services. They keep on developing more applications and so on. So the API registry and API gateway, ideally we should maintain these at the corporate level so that other developers, they should know how they're supposed to access some data. Not the database server, but the data as REST APIs. Okay, so keeping this in mind, let me show you this thing practically as well. There's a question in the chat window, what's the best way to implement an API registry? So good point. So like I mentioned, usually we prefer using some off-the-shelf solution. We have Apigee, we have API gateway on Azure, we have open source solutions as well, like WSO2. I actually have these listed here. So these are some of the very common popular solutions. Actually, there's MuleSoft as well. There's a solution from MuleSoft. You can choose to use TIBCO, Mashery. You can choose to use Kong, TYK, WSO2, Azure API Management, and Google has Apigee. So these are the off-the-shelf API registry / API developer portal / API gateway. The whole API lifecycle management is offered by these solutions. If you try to implement your own custom API registry from scratch, it will definitely be quite time consuming. You could look into the developer stack offered by Netflix. So Netflix has the open source stack for Java developers and other developers as well, where you can choose to register your APIs. Like we have something called Eureka. So Eureka is offered by Netflix. It is just the registry solution where you can register your APIs and discover the services. But it's not a full-blown API lifecycle management solution. It is just the registry portion. Whereas these are full-blown API lifecycle management solutions. So the entire lifecycle, like coming up with this strategy, mocking data, if you just want to quickly test some URLs or REST API endpoints, then you can develop your REST APIs, you can manage them, secure them, implement and enforce policies. So if you want to do the whole thing, then you need to look into a proper API lifecycle management solution, such as one of these. Okay, so there's another question in the chat window. What about Swagger? Definitely, Swagger is an awesome solution, but it's not the full-blown API lifecycle solution. Swagger is basically the design portion, this part, or actually this one. So designing your APIs. And I'll talk about Swagger as well in just a bit. So let me show you a demo. I'll talk about Apigee as a case study in this case. It's a full-blown API lifecycle management solution. Where is Apigee? I have it open in one of the tabs here. Okay, so here I'm already logged into my Apigee portal. So here we have various options. So typically we start off with the design part, that's known as specification as well. So APIs should be designed first. So we should give a specification to the developers that this is what the APIs should be like these are the endpoints and so on. So here we can click, let's say spec here. We can create a new specification. So each specification is essentially a YAML file. You can choose to use JSON as well, but YAML is more user-friendly. And here we usually design what endpoints we should have. So what we have on the left-hand side is basically getting displayed like this in a more user-friendly manner or sort of developer-friendly manner. So what base URL we should have, what endpoints we should have, what parameters we should pass, and we can even click the try it out here for this sample service, and it will basically let us customize the parameters, and you can see the response as well for this sample service. So you can basically create the specification so that developers should know that, okay, if this is the endpoint I have to design, I must return this type of data. And as part of your data, we usually create models. So even models are available here as part of this sample specification. So person should be composed of name, display name, and subscribed in this particular scenario. So you can basically create your model along with your endpoints, what model should be returned or received by your requests and responses and so on. So this is basically also known as the Open API specification, OAS, Open API specification, and it's also called Swagger as well. So Swagger basically came up with this specification, and now it has become open source and very widely used specification. So you design these APIs first, and then developers will look at this. Even testers will later on be able to use the same thing to test out the developed REST APIs and so on. And in more advanced cases, you can generate the code as well. So here we don't have the time to talk about how we can generate the code in Java with Spring Boot or Node.js from the specification. So from the specification, you can generate your code as well. And then next, you usually get to expose your REST APIs through this gateway. So whatever API you have developed, do not ask front-end developers to directly call it. Because if you do that, you cannot enforce policies and compliance requirements and rules and regulations at the corporate level. So in order to ensure that we can enforce some policies at the whole organization level, we get to expose the APIs as proxies. So here we can choose to create a proxy and connect it to some underlying API. And as a case study, I'll show you how we can modernize old SOAP XML-based services by using this API gateway without writing even a single line of code. So without writing any line of code, we will modernize this thing. So for this purpose, let me quickly open up this particular SOAP UI tool. So I can first of all show you what it looks like, and then we will see how to modernize the API or the SOAP XML service without writing any line of code whatsoever. SOAP UI, it should be this one. How many guys have used SOAP UI before to test APIs or SOAP XML services? So some of you guys have used it, that's good. So I'm going to show you that it's the typical traditional SOAP-based service, SOAP XML service, and we will modernize it. We'll convert it to REST API without writing any line of code whatsoever. So here we have this SOAP UI interface open, and I'm going to show you a sample service. It's available here. So this website has a bunch of services, like we have this temperature converter. We have a couple of services here, like Celsius to Fahrenheit, Fahrenheit to Celsius. So I'm going to copy this particular URL, or actually I already have, or this should be the one. So we can take this particular URL, and you can choose to look at its description. So WSDL, we can look at its WSDL, and notice that this is the typical traditional SOAP XML based service. It's not the REST API, and we need to modernize it. We need to convert it to REST API without writing any line of code. So I can take this particular REST API, or sorry, the SOAP XML based URL. I can test it out here first. I can click SOAP. I can enter the WSDL here, name your project whatever you want. I can enter the WSDL here, and notice that it will be able to identify how many services we have here. So we have Celsius to Fahrenheit, Fahrenheit to Celsius. Let's use this one. I'll send a request, and you will notice that we have the SOAP XML based technique here. This is the typical traditional SOAP XML based service. So here our function name is, or the method name is Fahrenheit to Celsius, and it requires this parameter temperature in Fahrenheit. I can change this question mark with some value, send a request, and we will receive the response in SOAP XML again. So the value is 37 point whatever. So this is our legacy SOAP XML based service. So I'm going to expose this service through that API gateway and modernize it so that it's available to us as a modern REST API. So how do we do that? So for that, we can go to our API gateway solution, such as Apigee in this case. You can actually sign up for Apigee for free. You get a 60-day trial, or you can choose to pay for it, or you can choose to install it on your local servers as well if you want. And then next, we are going to expose it as a proxy. So this API gateway is going to connect to that underlying legacy SOAP service. I'm going to specify the URL here. I'm going to validate it. It will identify how many services we have, or services we have here. I already have this thing pre-created. I'll change it to something else. I'll just call it temperature converter, or just maybe converter. And this is the base path I'll be able to use. The underlying service URL is this one, but I'll later on access it through the API gateway. So next, I'm going to click next. It will list all the operations that are supported by that particular service. So it has identified that it has Celsius to Fahrenheit and Fahrenheit to Celsius. And REST API wise, we can choose to change some of these conventions, like the path can be changed. You can also choose to use various verbs like get, post, put, delete, depending on whether you're going to perform the read-only get operation, or you're going to perform the insert or update or delete operations. So based on that, you can choose to change your verb here. So for now, I'll keep it as it is. And you can choose to change this part if you want, but even this, I'll keep it as it is for now. Click next, and next I'm going to tell Apigee that it should be available both in HTTPS as well as in just the plain vanilla HTTP sort of protocols. Then next, here now we can choose to deploy, publish these APIs and make them part of our API registry. So API registry is where we need to make sure that it's registered. So the underlying URL will be this one, but for now I'll just use a test environment. So we're assuming that we are still working on it. It's being tested. We don't want to make it production ready yet. Okay, so once your service is exposed, notice the URL is radically different. So previously we had learnwebservices.com/whatever. So yes, we do want to connect to this underlying service, but we are going to go through this particular layer, API gateway layer. So all front-end developers or the client developers will end up using the new API gateway specific URL. So notice that the last bit is letting us know that we want to call or access the converter service, but the first part, the domain name, is radically different. So here, once you're done with this part, you can actually make a note of this URL if you want. and let's test it out. So for this time around, I'll use, let's say, Postman. So Postman is a REST API testing tool. It's optimized for REST API testing. So previously we had SOAP XML all over the place, whereas this time around, now that we have the API exposed, the SOAP XML service exposed as a modern REST API, we'll be able to use this sort of URL here. So to save time, I already have most of the stuff configured here. I'll just change this last bit here. So converter. Okay, so I want to send a request to this particular API gateway based URL. I want to call the REST API this time around. This is the REST API URL. If I click send, we can see JSON data is returned this time. So even though the underlying service is the legacy SOAP XML based service, since we have modernized it without writing even a single line of code by using API gateway, so it's using the modern standards automatically. So we have the response in JSON format this time around. And even this format can be changed as well. Like you don't want Fahrenheit to Celsius response, you can remove it. You can rename this thing. You can modify the values by using, so if I go to, let's say, this proxy that I've created here, you'll be able to add some policies here. So I won't go into too much depth for now. I'll just show you that at the corporate level, you can use the declarative technique. Like you can use some XML-based tags here along with the graphical designer, and you can say you want to change the format, you want to enforce security, you want to remove something from your response body, or you want to add something to your request headers. So you can basically do pretty much anything here at the corporate level that you want. So basically the beauty of API gateway is that you get to still utilize your underlying APIs, but you expose them through that gateway. So this way you're able to enforce some policies in a declarative manner. So here I showed you that even without writing any line of code whatsoever, we have modernized an existing real world service hosted on some website, and we have it exposed through our API gateway. And now you can choose to add some policies in a declarative manner. And usually after that, you can also choose to say that we need to sell, or maybe not always sell, but we need to provide the service to different types of users or applications. Some applications will be mission critical, some applications will not be mission critical. So we need to vary the performance purposefully. So you can basically say that a certain client application should only be able to call it maybe 1,000 times per month, or maybe just 10 times per second. And likewise, you can also specify how many simultaneous requests can be made. So in order to control like who should be able to call the service how many times, usually we package it as a product. So we publish this particular proxy as a product. So we can go to this publish, we can go to API products, and we can say that a certain service, we can add a new API product here, name it whatever you want. I actually already have it configured here for one of the services. I'll just go to this one to save a bit of time. So here we can say that a certain service that is now exposed through that API gateway should be available as a product, and you're also allowed to change its configuration. Like you can configure quota, how many times you're allowed to call this service per month, and so on, depending on how mission critical your application is. And then you can also choose to create a portal here. So in the developer portal, you can choose to register your products so that developers can find out how many APIs we have, what's the URL, what's the documentation for that URL, and so on. So basically, the benefit you get with API management is that you get to explore whatever APIs we have at the corporate level. You get to sign up. So signing up basically means you can say that a security key or token is mandatory. You cannot call the APIs as is. You need to pass an API key. So previously, I didn't make it mandatory to pass the key. I was able to call the URL. Anyone can use this URL and access the underlying API. But in real world scenario, we configured policies so that a security token must be passed as part of your request header or as part of your URL itself. So you can enforce that, and then you can basically monitor who's calling your services, how many times they call the services, and based on monitoring, you can also choose to monetize your services. You can build them accordingly, and so on. So all these capabilities are available in most professional off-the-shelf API management solutions, such as Apigee, Azure API Management, MuleSoft has a solution as well. TIBCO has it. Kong is there. TYK is there. And in fact, there are lots of open source, free of cost options. Like these are totally free of cost, and this is in fact open source as well. Even TYK is available as a free option. Apigee is also available as a free option if you want to install it in your on-prem environment, or you can choose to use it on cloud as well if you want. Some people use Nginx along with WSO2. So Nginx acts as the reverse proxy, and WSO2 is later on utilized on top of it, so that we can make sure that all APIs go through our API gateway, and we get to enforce the policies at the gateway level. So basically, the point is that we need to control things at the corporate level. So APIs, yes, they're awesome, but how do we control things? How do we standardize things? API gateways, what we get to use for that purpose. And we do have various courses on this topic. Like one of the courses is API Management Fundamentals for Architects. So if you have any interest, you can definitely look at the outline if you want.